Good morning. Today's video is going to be on the periodic table. And the periodic table is the giant thing that's been on the wall the whole time that we've been in class. You've probably wondered what it was. This is the shape of the periodic table in general. Before we talk about the periodic table, though, it's interesting that the periodic table is a man devised feature. It's not something that just we found, somewhere in nature. It was discovered, or it was produced or made by a Russian scientist. His name was Dmitry Mendeleev. Here's a picture of him, and he has a very interesting story. He was born in Russia, and this is in the 1860s. So around the time of the Civil War in America, Mendeleev was putting together the periodic table. And the reason the periodic table exists, and the reason it's called the periodic table, is because Mendeleev noticed and organized the table according to similar properties. And what that means is, if you look on a periodic table, the columns here, these are known as families. And Mendeleev noticed that the families, these are all different families. And the families actually each have names, just like your family. So all of these, there's 18 families. Here's a family. These 18 columns are called families. And he noticed that within a family, the elements have similar properties. So for example, this family is known as the alkali metals. And they have an interesting property that they react violently with water. In class, we're going to watch some sodium and some potassium. This is sodium, this is potassium, this is sodium, this is potassium. They're going to be dropped in water, and you're going to see a violent reaction. And that's a property that only these elements have. And so he knew that they must be related, so he put them in a family together. These are a different family, and they have similar properties, and so on. And so the fact that the families will tell you the property allows you to make some predictions. If, for example, when Mendeleev was developing the periodic table, this element had not been discovered yet. This is gallium. But he knew the properties of aluminum, which is this element, and indium, which is this element below here. So he was able to predict what gallium would be like. And lo and behold, when they found gallium and they measured its properties, they found that it was exactly as Mendeleev predicted, and that was validation that his periodic table was correct. Okay, so now about the big picture of the periodic table. We know now that these are called families, and they're numbered. So this is family 1, family 2, family 3, and so on all the way over to here. This is family 18. This family has an interesting name. They are called the noble gases. Whoops, let me write that down here. They are known as the noble gases. And they have a property that's very unique. They don't react with any of the other elements on the periodic table. They stay to themselves. They're kind of the loners, if you will, of the periodic table. So some interesting things there. Now, the periodic table as a whole is broken into kind of three sections. The majority of the periodic table, the elements on the periodic table, are what are considered metals. And when you think of a metal, you think of something shiny, something that you can bend, and so on. And those are all properties of metals, and these are all metals. So the majority of the periodic table are considered metals. Now, if you look on this periodic table, and if you look at the one in the book and you look at the one on the wall, you'll notice a zigzag line. And the zigzag line is a kind of a dividing point on the periodic table. And what it's separating the elements that have metal properties, that are metals. So they're shiny. They conduct electricity. They conduct heat very well. You can bend them. On the right, these are the nonmetals. They are gases. They are either gases or solids. There's one liquid in this section, but for the most part, the solids are not shiny. They're dull. They don't conduct electricity. They don't conduct heat. And so they have very different properties. And then right on the zigzag line are just several elements right touching the staircase that have properties both of metals and of nonmetals. If any of you have a computer, right here is the element silicon, and here is the element germanium. These two are very useful in computers because in a computer you want something that in the very tiny circuits that make up the inside of a computer chip, you need something that conducts electricity a little bit, but not too much, because you don't want to overheat and melt the circuit. And so silicon and germanium are used in computer chips because their properties, a little bit of a metal, conducts a little bit, but it doesn't conduct too much electricity. So let's move on. Look at this next slide. So here are some properties of metals. These you probably just know intuitively. We know metals, if you think of metal like a copper, like a copper penny, they're good conductors of heat and electricity. This is a word that you probably haven't heard before, malleability. And malleability is the ability to hammer into a thin sheet. And in class, I'll actually pass out some sheets of metal. You'll see some lead, you'll see some iron, you'll see some copper. You can't do that with a non-metal, something like oxygen or sulfur. You just can't put it into a sheet. This word ductility means they can be made into a wire. And then obviously the last property of a metal is they're very, very shiny. They have luster, and that's a science word for shine. All right, a couple more things to talk about with the periodic table. I mentioned in the first slide, the first clip, that the up and down parts of the periodic table are called families. There's 18 of them, and they're numbered here. This is family 1, family 2, and so on, all the way over to family 18. Now, families can also be known. So you can call, as you go up and down the periodic table, these can be called families. They can also be known as groups. Sometimes, at the chemistry party, you might hear someone say group 1 or group 2 or group 3. The other thing that's interesting is you go this way on the periodic table, left to right, these are known as periods. So this is period 1, period 2, period 3, period 4, period 5, period 6, and period 7. So there are 7 periods on the periodic table. Now, of the families, there's 4 that have names that are very useful that I would like you to memorize. Just remember, this is family 18. It's called the noble gases. And I often say it like that, noble gases, because they don't interact with any of the other elements. They're too good for that. And we'll talk later why that is they don't react, but for now, just think of them as the snobs of the periodic table. The next family I'd like you to know the name of is right next to the noble gases, and it's right here, and these are known as the halogens. Now, the halogens are interesting because they are the elements that will just rip electrons away from anything that comes in their path. And you might say, well, why is that important? Well, if you take a look at this is chlorine, Cl. Think about what is chlorine used in. It's used in bleach. It's used in swimming pools. It's used in drinking water. And why? Because it kills bacteria. And how does it kill bacteria? Well, bacteria are very small, and by ripping away electrons from the bacteria, you can kill the bacteria. And that's effectively how chlorine works. Here we have the alkaline earth metals, and then this first family is known as the alkali metals. All right, one last thing about the periodic table is this section here in the middle. These are still metals, but they're known as transition metals. And the reason is because as you go from left to right across the period, the properties of the elements become less metallic and more metallic. So potassium is the most metallic element in this period. Krypton is the least metallic. And this is kind of a transition stage because they're slowly changing from metal to non-metal. I call this the Northfield campus of the periodic table because when you're at Northfield, that's a transition year between middle school and high school. You're changing from a young boy to a man or a young girl to a woman. And that's what's happening here. They're transitioning from metal to nonmetal. And of course, note the number at top is the atomic number, and our periodic table on the wall has a number at the bottom, which we said was the atomic mass. And this number, the atomic number, tells you what? If you said protons, give yourself a prize. Whatever you want. Free dinner. How about that? All right. Let me know if you have any questions on this video, and I hope you enjoyed the tour of the periodic table.